Thanks for watching this screencast. The objective of this screencast is learners will be able to determine the sum, difference, product, and quotient of two functions. So we're going to let f of x and g of x be two functions that are already defined by some rule. And then we're going to define four brand new related functions based off of those two. We're going to define the sum function, the function f plus g of x. But simply the rule for finding the sum function is to add f of x and g of x together. We're going to define the difference function, f minus g of x, as whatever f of x is minus g of x. We will define the product function, f times g of x, as whatever f of x times g of x is. And we'll define the quotient function, f divided by g of x, as f of x divided by g of x. Now, notice the important caveat for this function. G of x cannot equal 0. That'll come into play when we discuss the x values that don't work for the new function f divided by g that might have worked in function g of x. So let's show you an example of what you're going to be asked to do with this concept. Here are two functions. F of x is x squared plus 3x minus 4. G of x is 3x minus 2. Let's find the functions f plus g of x, f minus g of x, f times g of x, and f divided by g of x. We'll do them one at a time. So to find f plus g of x, all I need to do is take f of x and g of x and add them together. F of x is x squared plus 3x minus 4, and I'll add to that g of x, 3x minus 2. Now, I should simplify this. I should write this in standard form with like terms combined. So I really have x squared, 3x, and 3x combines to make 6x. And negative 4 minus 2 is negative 6. So there's the rule for the function f plus g of x, x squared plus 6x minus 6. If I wanted to do f minus g, all I need to do here is take f of x and subtract g of x. So here I need x squared plus 3x minus 4. And I need minus the entire function g of x. Sometimes I've found students will get really sloppy here and they'll only put the minus sign without parentheses. You need f minus all of function g. So what that's really going to give you here is x squared plus 3x minus 4 minus 3x plus 2. Get rid of that and use that instead. So to write this in simplest form, I've got x squared. 3x minus 3x is actually 0, but negative 4 plus 2 is minus 2. And there's my answer. That function gives me f minus g. We can do f times g of x. That's simply going to be whatever f of x and g of x are multiplied together. So what I really need here is x squared plus 3x minus 4 times 3x minus 2. Now, in the first semester, you saw this modeled with that box multiplying. That's what I'll model here too. If I want to multiply x squared plus 3x minus 4 by 3x minus 2, I've got 3x cubed. Here I'm going to have 9x squared plus 9x squared. Negative 4 times 3x is negative 12x. Negative 2 times x squared is minus 2x squared. Negative 2 times 3x is negative 6x. And negative 2 times negative 4 is positive 8. And if I want to write that in standard form, and I do, I've got 3x cubed. 9x squared minus 2x squared is plus 7x squared. Negative 12x minus 6x is minus 18x. And I got my plus 8. Finally, let's do f divided by g. And that's just simply whatever f of x is divided by whatever g of x is. So that's going to be x squared plus 3x minus 4, all divided by 3x minus 2. Now, in a previous learning target, we showed you how to divide polynomials. You actually could simplify that more if you wanted to. For this learning target, it's really okay to leave that there. There is one more thing, though, that's important to remember. Remember we said that g of x can't be 0? Well, we want to figure out what value x can't have. So I want to say g of x, 3x minus 2, can't equal 0. And that's only true if x is not equal to, this should say can't equal. That's only true if x is not equal to 2/3. So that's an important part of your answer. So let me go back and hit my answers real quick. There are 4 in this problem with some highlighting. Here's my f plus g. Here's my answer for f minus g. Here's f times g. Here's my answer including that restriction for x values in the denominator on f divided by g. You know what time it is. Here's one for you to try. Hit pause on scratch paper or somewhere where you've got room. See if you can work these out. When you've got answers you like, hit play to get some feedback. For f plus g of x, all I really need to do is to add x squared plus x minus 6 to x minus 2. And I get x squared plus 2x minus 8. For f minus g, I need f of x, x squared plus x minus 6, minus the entire function x minus 2, which really makes this negative x plus 2. So I've got x squared, my x is canceled here again, minus 4. That won't always happen, just in the 2 we did. Coincidence. For f times g of x, here's where I need x squared plus x minus 6 times x minus 2. I really am a box multiplier. That area model works so well. To multiply x squared plus x minus 6 by x minus 2, x times x squared is x cubed. X times x is positive x squared. X times negative 6 is negative 6x. Negative 2 times x squared is negative 2x squared. Negative 2 times x is minus 2x. Negative 2 times negative 6 is positive 12. So what we're going to get here for f times g is x cubed. X squared minus 2x squared is negative x squared. Negative 6x minus 2x is negative 8x. And plus 12. Finally, we need f divided by g. That's going to be x squared plus x minus 6 all over x minus 2. And yeah, x can't equal 2. Because if x did equal 2, then g of x would be 0. Now, that would be a perfectly acceptable final answer. But if you want to earn some cool Algebra II Honors brownie points, check this out. That numerator can factor. I could write the numerator as x plus 3 times x minus 2. And something that's important for you to know is that you can divide factors out of fractions. So if x minus 2 is a factor of both, I can divide them out. So if you want to get those extra cool brownie points for going the extra mile, x plus 3, as long as x doesn't equal 2, would be a totally acceptable answer as well. Although again, this would get you full credit in our course. How'd you do? Thanks for watching.